Okay, Assalamualaikum and good morning everyone. So today I would like to show the demo for my simulation for my project. So this is the coding I used to generate the irradiance data, the load data and the module temperature data. So this is the coding that I used to generate for 3 types of models of irradiance data. Okay, this is the coding. And how do I get this value? I get it from the Excel files that I get from Dr. Ghani, which is the actual solar irradiance profile for 31 May 2014, 1 June 2014 and 2 June in 2014. So this is the irradiance from 12 AM until 11:59 PM. Okay, so we copy this data and we put it into the editor part. Copy and just paste. Okay, we copy and paste, and then this is recording to generate for the 24 hours in a day, and this for time. We have to tally the time and y. So this we can plot this time and y. This is for the x-axis and this is for the y-axis. The function of this is to generate the signals in the simulating later. I will show it. So we can run whether it is correct, the irradiance data. Okay, so this is the data for the irradiance that we will create in the signal builder for the simulating. It is 24 hours time. And this is the actual irradiance data for model A. So we can move to the simulation. Okay, so how do we create the signal builder? We delete it first, and then we click signal builder. So from the signal builder, we can generate the irradiance, module temperature and load data. So we have to change the time range to 24 because we use 24. Okay, and then after we change the time range, so we click signal, new and custom. We put it time for the x-axis and y for the y-axis. Where do we get this value? It is from the editor part we used before. Okay, it is from this value, which is the time and y value. So after we put it, it will generate same as the previous that I have shown. So we delete this first for the signal one. Okay, so this is the irradiance data, the actual irradiance data for 24 hours on 31st of May 2014. So we can change it to irradiance. We can rename it to the irradiance A because we have the model of irradiance data which is A, B and C. Okay, so this is for the irradiance. So we have irradiance A, B and C, as well as temperature A, B and C, as well as the load demand, actual load demand from the loghouse. So the PV panel we choose is the parallel string is 26 and the series connected module per string is 5. And the maximum power generated is 230.124 watts for one module or one panel. Okay, for the battery part, we use lithium ion battery that I have mentioned in the methodology part. And the nominal voltage is 48 volt and the rated capacity is 4900 ampere hours. And the initial state of charge is 30%. While for the nominal battery value is 48 volt, which is the DC bus voltage, because the system capacity is more than 2.5 kilowatt, so that we choose 48 volt. Okay, then I will run the simulation and we wait for 10 minutes because the simulation took quite a long time. Then I will continue for the output waveform parts. Welcome everyone. Okay, today. Okay, the simulation has been run, and it takes between 5 to 10 minutes. So that's why I skip. Okay, we look at the PV parts. So we can look at the irradiance, PV voltage, PV current, and PV power. So how do we know the irradiance value for the power value at 10 AM, 1 PM, 10 PM, 3 PM? So we can click at this to the selection, which it can measure at certain time, which means we click 10 AM and 1 PM. So we can look at the irradiance. Okay, the value at 10 AM is lower than at 1 PM, and for the PV power, the PV power is higher at 1 PM, which is 16,900 compared to the at 10 PM, which is 7,694. Yes. Okay, and for the irradiance, it is 539, and for the at 1 PM, it is 977 watt per meter square. Okay, this is for the solar. So as well as we look at 10 AM, we can look at 10 PM. So this is at 10 PM. We can look at the graph, as well as for the battery parts. We also can look at the cursor measurement. This is at 6 AM and this is at 6 PM. Okay, I want to show at 10 and 1 PM because we can look the graph at the state of charge. Okay, this is the graph for the state of charge. We can look at it is in charging state. The value is not a big difference. It's between 0.01% between each value, which is we can look at this. This is 29.9969, and this is 29.996, 29.9977. So it's a small range difference for the state of charge, but it's still in the charging state. So we can look at the battery current. So the battery current is in negative value. We can look at it is negative 32.88 amps, while at 1 PM is negative 86.44 amps. Okay, we can look at the negative part of the battery. It is in the charging state for the battery. Yes. Okay, this is the load demand and the battery voltage. It is inversely proportional to the battery current. For the battery voltage, when the battery current decrease, the state of charge will increase as well as the battery voltage. So this is the simulation part. This is the PV system design. In this is part, and this is the applicability control. It is to detect the power condition of the PV panel, which means it need to supply the maximum power to the battery part as well as to the load part. And this is the battery part. This is the switching for positive and negative for the battery. This is the battery monitor. We can look at the scope or at this. And this is the inverter that I have taken from the online sources. And this is the variable resistor used to represent the load demand for this village or longhouse. Okay, so I think that's all for my demo video. Thank you for listening and watching, and Assalamualaikum. Okay, before end, I just want to show the data for the 21 May. This is the irradiance data, and this is the panel temperature data, and this is for 1 June. As well as 1 June is also for 1 minute interval, the irradiation and panel temperature data. This is the graph I generate from this data to compare with the in the simulation part whether it is correct or not. And this is for 2 June, the irradiation data and the panel temperature data, and this is the load demand in kilowatt. And this is the load demand for kilowatt with 15 minute interval. So we can see the base load is at around 8000 kilowatt and the peak load is around 8000 kilowatt. Okay, I think that's all. Thank you.